Welcome to another teardown video. Radiometer Copenhagen. Danish high quality. Look at that. So this is a pH meter. It can also measure temperature or millivolts. You can of course turn it off. So the idea is you put your probe into a buffer solution and set to the value that is written on the buffer solution. And then of course you dial the temperature in to the correct temperature, and then it will read out the correct pH. This is how all pH meters works. This one is battery powered. I'm sorry, but I don't have the battery lid, but I can see how it was locked with these two. Everything here is really nice quality. Super good and stable made. Nice and clean, by the way. And look at this. Really nice and springy. And this sharp edge here for really good contact. So I would assume this would work. Let's try and connect this to some DC voltage and see if it's alive. So it is that simple. And 9 volts. Should we just give it a half an amp? Just to be sure. We got plenty. Keep it in off. Power on the DC supply, and it reads absolutely nothing. So we're going to pH. Oops, it's alive. And this is only 2 milliamps, which is expected because this is battery powered. So of course it cannot use a lot of power. So the 2 milliamps. Also 2 milliamps. Ooh, aha, that is funny. I didn't expect that. So this is, aha, so this is how it's done. So you put this for Celsius, and then you set the temperature that you know is in the room. So you manually, ooh, it is impossible. What the heck? It's just, there is something wrong with this potmeter. See, it works in the low end, and then it's just, yep, there's a hole in the potmeter, and then it's working again up here. All right. I think I can actually feel there's a problem with the potmeter, so that could be fixed. Millivolts, so we are reading the millivolts the probe is reading. And if we go to pH, of course the buffer will change whatever reading the millivolts is converted to. So the thing is, they're using a really odd special plug. So it's not intended for you to access this connector. See, this is the release, and if you Google the connector for these, it looks like a jack, but it's not. So it's their own special connector. So I don't understand what is ref. Maybe I should try and measure. Is something coming in or out of this? I will get back in a second. So here's what I'm trying to do. trying to connect my millivoltmeter into this one in millivolt mode. So I'm just trying to push in those and see what happens. Haha. Oops. So now I'm connected. 0 millivolts input and 0 millivolts reading. So it seems like this is a really good millivolt meter. What I will try and do is open this up. Yeah, what we need to do is open. It's time for opening. Yes, how do we open? Let's pull this off. Open, 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 yeah. Let's get a screwdriver. Alright, so here's what I did. I took off all the 4 screws in the back, and I would assume, yeah. Maybe. This seems to be a little bit stuck. Oh, come on. I would really want this to go. That is not going to happen. How about the other one? No chance. So that means this is in one piece. Wow, I didn't expect that. And also you see here, some metal here goes under this. So how the heck do we... I think we should maybe try and take off these screws. Is this how it's done? I have no clue. As always, the clueless dude is doing clueless things. Oops. And then what? Ooh, some more happened now. Okay, we are more in. Aha, it's full of... Ooh. I got a feeling this was not the way. How the hell do you open this thing? Ah, okay. If in doubt, here is the trick. Use more force. If it doesn't work, get a bigger hammer. So those are the good strong grippers. Look at that. Gripping onto the... All you have to do is just pull real hard. Ooh. And all sorts of little metal thingies are going on. Oh, look at that. That is really well made. Red and black. Okay. I think we got it. I think we got the idea. And here I still have... That was the last screw. Look at all that. So that is the good standard LCD driver chip we always see in older equipment. Operational amplifier and some, what is that? 4030 and 4030s. Why can't we get this damn thing to focus? Hello? Come on, here we go. Look at this PCB in a super beautiful quality. What is in there? This is where all the magic happens. Oh, look at that. Look at the wire here. So this is the wire that is the chassis. So chassis here is not connected to this one. That is connected to the red is the reference for this one. That is a little bit unexpected. I did not see that coming. Wow, so this one is isolated in plastic, and then this metal here is the red one. Wow, interesting. So this is our signal input, and this is chassis. All right. So, and the other part here is not connected. We got a few trimmers. Just too bad they don't say exactly what is what. I would really love some text saying, oh, this is the temperature, or this is the humidity, or this is this and that and fantastic things. Then it would have been easier. Look at that. So this is the standard profile you use for these connectors to hold them and to do this click thing. And the distance between these are of course fixed by this metal system here. And look, there's of course room for another one. And they just didn't use that. So you just click these in, and then you have this piece of plastic going back and forward, and this is the holding or the release mechanism for the switches. Really often used, and you can of course change the switches for the length you need. Potentiometers, look at this. This is the shielding for this metal plate. So this is connected again. See? There's a chassis symbol on the PCB. Going where? Going somewhere else. Probably going the same place as this other switch. But it's really nice. Also, when I was playing a little bit with this, I fell in love with the mechanics here. Look at that. It's just fantastic. You can see you can of course pull this up for release, but you can also see the way that they etched the aluminium handle so that it will go in here and lock. And also this is etched, so you have this click and then you can push it. Absolutely fantastic quality. I love it. Let's try and give this some millivolts and see how well it performs, shall we? And we are back. I connected again 9 volts of DC. So input voltage, and then I'm measuring the voltage at the connector. So it's reading 23, between 22 and 23 millivolts. And I think this is about what we got, right? Let's try and give it a little bit more. See if it's also accurate for, like, what is that, 70? So this is, it's impossible to see. 72 millivolts, 72.6. So it's really accurate. Let's see if I can give it 172. Yes, it's still 2, 3. How much can this really read? About a volt? So we got ourselves a really nice millivolt meter. because I don't have the probe or the connector or anything. So that is 174. And yeah, it says 174. I would give or take. I would call it good enough. It's just amazing. I don't know how old is this, but it reads to the last digit. How much can this do? Oops, yeah. And that is quite typical for pH meters. They will do a little bit under 2 volts. So this is 1974, it says. 1974. This is just absolutely insane quality and accuracy. How have they done this? There must be some magic thing inside this one. What have we got in here? Haha. We need to open. So now we're in here. And this is the input from the pH meter. Look, the signal goes through a 100 mega ohm resistor. Then there's a decoupling capacitor and then 1 mega ohm into a little transistor opamp circuit. And again, the standoffs, they're in Teflon for ultra low leakage. And even the connection between the transistor and the opamp is made with flying leads. They don't want this to go into the PCB for leakage. Absolutely fantastic design. And here's the money shot. There's a reference. And this is of course why this thing is so accurate. Here we go. So there's a really, really nice reference here. Maybe we can, I'll see if we can get the CL18690, what? Come on, DC5Q, is that right? Or is it SQ? Come on, man. Yeah, SQ. So this is probably a 2.5 volt. This is just my guess because they are normally looking like that. And they're very, very good and accurate. And of course, this is why this thing works so well after all these years. Look what I found here. Year, week code, 8608. So it is really that old. This thing is manufactured in 86 and it is accurate to the last millivolt. Wow. They're just super good. And also, what I see here is all metal parts connected to ground. And they're repeatedly doing this all over the place. And this is just so good for ESD handling, that everything is connected, all metal parts, they're just really well connected together. And this is why this thing just continue to work after all these years, because it's made right. This is how you do it. All right, I think I will assemble this again and call it a good thing. I really should find something to complain about. I must say, holding this little thing in there and get the screw in from here at the same time into that hole and get it all right. Maybe I'm not using the right tools or the right kind of brain size, but that was a little bit difficult. So if you need to make 500 of these every day, I don't know, it's a little bit difficult, isn't it? See? this thing needs to go in here. Just, no, that was wrong. It is just not easy. I just love stuff to be easy. Why can't I have it easy? There must be a secret trick. It is to lift this up and get it in the hole and yeah, maybe. I don't know. And that took a half an hour to figure out how to assemble this little piece of metal in here. But the trick is use gravity as the secret force. Hold this thing down. Haha! Then it will stay exactly where you want it. And here, look at this. Of course they removed the paint where you put the screws. So there's good electrical connection all the way around. And this closes the circuit all the way around. So there's no hum, noise, or any bad things entering the circuits. These guys are just geniuses. I love it.